Hi everybody, welcome.
There's something that I learned when I went to chiropractic college, and it's especially true of motor skills where you're using your hands to adjust or something like that, is repetition is the mother of knowledge. So sometimes things need to be repeated before people get it. I talk with people about posture all the time, and they'll be sitting there hunched forward like this going, yeah, I get it, and I'm talking to them about posture, and they're shaped like a C curve. So it's one thing to kind of initially understand, it's another thing to really grasp the significance and importance of something. What I thought we could do is just do kind of a go-through of a lot of the things that I've covered in many different videos. And those of you who have been with the channel for a while have certainly seen some of this this research and the evidence, the empirical evidence that I'm going to be presenting for you today. And I'll talk about the different categories of investigation that I've done with regards to these stones. It all began with this rock, which I found in a river bottom, and I've done a lot of videos talking about this, and all of the different anatomical features that this rock exhibits that are identical to heart anatomy, this being the aorta opening and the vena cava. The white fatty outer layer is called the pericardium, and everywhere that the white is worn away, it's red inside and under that. And then this fatty line here, this is called the what is that? I can't remember the name of the fatty line, but this would be the left atrium and the left ventricle, and then there's a line here, right where the corona, the coronary artery goes, the coronary opening. This is called an isthmus. There's a whole bunch of anatomical features in just this one rock. That number's up to almost 25 now. I've gone in with endoscopic camera down into the chambers, and not only are there chambers there, but they're not quite what you would expect to find with water erosion, but rather they're bumpy, and that's consistent with what you would expect to see with heart anatomy, just as is that isthmus. And then those bumps there in each of the openings are what I believe are the papillary muscles, so the muscles that contract to open the valves of the heart. So there's a whole lot going on with that one. I got an endoscopic camera, looked inside, like I said. Bought a microscope that's sitting over there that is a 1000x microscope, Wi-Fi, and I've looked at a lot of these. And even though some of them are bone white, when you get up right next to them and you start looking at the grain of these things with the microscope, you can see that even though it looks very, very white here, it takes on a very fleshy look. You can see the fascia and the meaty quality of it, even in the white ones. But when you get to something like this, especially if you wet it underwater, and I'll do that with some, not this one because it's so big, but as soon as you get that wet, it starts to look very much like flesh. This is also very meaty looking, and if you dip that in the water, you can see that it looks more like a hunk of meat than a rock. So the whole thing began with this one, and I came back to my office and I pulled out the anatomy books for the heart and started to go through in detail with that, and found a whole lot more coincidences than I ever would have expected to find in a rock that matched heart anatomy, which was just totally mind-blowing to me. And then I decided to go out into the field and see if I could reproduce it, right? Because that's the whole thing with the scientific method. You make an observation, something in empirical reality, and you start to try and categorize the observations, right? And see if there's any kind of consistency to them, and if there's any kind of a pattern that starts to emerge, and is that pattern reproducible? And that's the whole point of it. So I made a couple of videos, one called Mud Fossils, the Heart of the Matter, and part one, that was just going through this first rock here that I showed you. And then I made a second video, Mud Fossils, the Heart of the Matter, part two, and that was back when I thought these were mud fossils. I didn't quite understand how it could be the case that they would be mud fossils, because why would you find a bunch of hearts outside of the body? It didn't make any sense to me. But I found the first one, and there were so many anatomical coincidences that lined up with it, and I'd already been introduced to this idea that petrification could happen far more quickly than we were given any idea. that there were lots of examples of that in the geological record of things that shouldn't petrify based on, what we were told. Hey, Dirt. Hi, Sherry. They shouldn't. Like soft tissue, we're told in the mainstream model is eaten away by the larvae and the bacteria that decompose the body, and so all that's left that fossilizes are your bones, basically, except in the rarest of circumstances. So for that reason, I think most of us are taught not to recognize these patterns. If this is really a thing, and we'll go into these in detail in a moment, that these are actually petrified organs, then a lot of the things that we were taught about geology are upended, right? So it's not something that the mainstream geological model will take in anytime soon. And so I've gone through a lot of different steps. First, I was just looking at the outer stones. Then I'm going inside with the endoscopic camera, the microscope. I sliced them open. We'll look at some of those. I've already made a video called Slicing Heart Stones, polished them with a grinder and then all kinds of different degrees of sandpaper. I've broken some open. I made a video called Broken Hearts Tell Tales, and went out into the field, found the exact same kinds of rocks exhibiting the same patterns that I've been teaching people to recognize in my videos, break them open, and sure enough, inside a lot of them basically look like they're bloody and meaty, and and a couple of them I really wish I'd brought back because they were such amazing specimens, and it would have been interesting to do some testing. I've had a lot of people that have asked me about DNA analysis. I have no budget. I'm in the hole on this project. 4 years and probably thousands of hours of my own time, and YouTube revenue is minuscule. So I don't have a product that I'm selling yet. I have a book that's coming out soon. Maybe it'll lead to some book sales, but it's on a completely different subject. So there's a lot of people that are like, you haven't done any science. You've got no data whatsoever. There's no proof. And I'm like, well, I've got empirical evidence up the wazoo. I have a repeatable pattern that is incredibly specific, that matches the anatomy of hearts in a whole variety of different details. And I spent 400 euros of my own money to have them CAT scanned. That was kind of a bust because the rocks themselves are so dense that it's like if you look at an X-ray, all the soft tissue will be dark, and then the bone will be white because the bone is, I can't remember what's happening with the radiation as it's hitting, but basically the soft tissue is going to be dark. That's why people do MRIs, so they can see the soft tissue, like for herniated discs and whatnot. So because the stones are so compact because they're stone, you can't really see much of anything. You can see the chambers that I already knew were there before I took the rocks in. So it wasn't. I didn't make a video about it because it wasn't the most exciting thing, and I need to buy the software just to be able to view the images again. It's kind of annoying. There was a cardiologist who contacted me who was really interested in what I was doing and totally on board with the conclusions that I had about these stones. And I thought I would get an analysis from him, but he went through a whole lot of struggle during COVID over a lot of different things, and so he prefers to remain anonymous, and we have contact now and again, and maybe he'll change his mind later. But so these people are like, you've got nothing, there's no evidence whatsoever. They haven't really gone through and reviewed anything on the channel. They're just having knee-jerk reactions based on preconceived notions about what is or isn't possible. And that's something I talk to people a lot about, is we're not taught to recognize this. If this is a real phenomenon, we're not taught that a stone could have a front and a top and a back and a bottom, and that those correspond to something that it was before it became a stone. Mainstream geology talks about these and says that these are what are known as polycalcitic conglomerate cobbles. It means they have a variety of different kinds of calcite, and cobblestone is like what you see on the pebbles on the streets when you're walking down these old villages, the streets of these old villages, you'll see these cobblestones. But their mainstream story is that those are basically lumps of clay that got compressed inside of other materials, and that created layers, and or that created these shapes. And I reject the notion, because there's so much repeatability and specificity to this phenomenon. All of the different hearts of the different species of the creatures, they're all different designs, but they have more or less the same design. But you've got 3-chamber and 4-chamber hearts, and you've got long, narrow ones, and you've got big, fat, thick ones, and you've got globular ones, and they can be shaped like this. This is like a miniature version of what a giraffe's heart would look like, to the T. So you can get these long, narrow ones, and then you can get bigger, rounded, fat ones. And I show pictures of an elephant's heart. But in general, what they all tend to do is have this kind of harp shape, and like the musical instrument. And harp, heart, I think it's interesting those words are so close together. And there's your aorta and vena cava openings at the top. So that one rock is exhibiting probably 8 to 10 different anatomical features, just this one rock. Some of them exhibit a ton of features, and others just kind of have that overall shape, and they're pretty nondescript. I just wanted to bring these out again, because this is my office. I work here adjusting people, and I can't exactly have these out, filling up the waiting room. So they tend to go into the closet, and then the longer they're in there, the more I start to kind of forget just how much evidence I've gathered in favor of this theory. And you can see that even, see my finger here, when we're getting down to these smaller sizes, all of the detail is still there in these tiny little rocks. It's the exact same pattern reoccurring. And you can see the indentation there at the top. That would have been where the blood vessel would be. This one's shiny because it was in my pocket for a while. You can see a chip is missing from it. Put them in a pocket for about 2 weeks, and they polish up very nicely. You don't have to run them through a tumbler. But you see that shape, and we'll talk about that in a minute in more detail. But what is ultimately, it's not proof based on some kind of instrumental experimentation, like looking at, say, spectroscopy or something like that. This is looking at this is pattern recognition and repeatability. So we have a scalability. It goes from tiny up to very, very big, same exact pattern. We have it occurring across lots of different colors of stone. So it's not just a particular kind of stone that just happens to break off and erode in this way. And then there's a whole bunch of other things that I'll go into in a moment. The specificity is what really makes it. When you've got the blood vessels there, you've got the things like this isthmus and this opening and the papillary muscles, and you find that, oh, here's a big harp shape again, and there's the isthmus, and then there's the opening, opening to the, So then if I just looked at this from the front, and I see this tapering and curving, that happens because when the heart goes into contraction, it actually twists like that. That's another very specific feature that these stones regularly are exhibiting. But here on the backside, you can see there's the sulcus line, and then you've got the aortal opening right there again. So that's about a 10 or a 12 at least in the what I jokingly took to calling the Wilkerson scale, because this is not, I'm not the first to talk about petrified hearts. Michael Tellinger had a video before, and a guy named Alan from Mudflood was Armageddon. He had been talking about it as well. I hadn't seen either of those videos before I found this one. I'd seen stuff from Mud Fossil University, and then I found this one, and I sent him a copy of the video. And I'm like, you're welcome to use that. And he didn't. So I'm like, okay, well, if he's not going to do it, I have to do it. So I did it, and then I went out and I started to find others. This one is really beautiful. You see that knife edge and that curved underside. Now, looking at it from this angle, I would expect there to be some kinds of openings or indentations at the top. And guess what? Right there, right where it should be. So, yeah, cherry picking in the sense that for every one of these I brought home, there's probably, or brought to my office, there's probably 100 that I've left that also match these patterns. So, in that sense, yeah, cherry picking, because I've focused on the hearts because they're the most distinct. They're the easiest to spot. Even though the heart can be round and globular, short or long, all of these different shapes, the basic anatomical features are going to be the same. So if you're finding that in spades, in stones, chances are they might be hearts, right? Even though we're told it's not possible and that soft tissue only in the absolute rarest of circumstances can petrify. But we know from people like Girolamo Sagato that he knew in the 1800s how to turn different kinds of flesh to stone. There's examples of petrified tree stumps that got hit with high tension power wires. There's places like Mother Shipton's cave where they hang things in the cave and within months they're starting to become crystallized and hardened. Same goes for Lake Natron, really high mineral content waters in this, I can't remember where it is, Lake Natron. Creatures fall in these waters and they don't come back out. So there's lots of things that suggest this is possible. It's not such a harebrained idea. Some of them are even dark, and I think this may have to do with species that have a different color blood from ours. But you can see the incredible, exquisite detail of this stone. And again, there's your blood vessel openings at the top. So it should be very hard for me to find this sort of thing reoccurring over and over again. Different theories that other people have presented in contradiction to mine. Some have thought they were teeth, and I don't believe they are primarily because of the interventricular sulcus. And what I mean by that is if you're thinking about like a canine tooth, the sharp ones that are tearing the flesh, they're one piece. And there's none of these lines going through the tooth. Molars have the lines, but the molars are four sections, and so you've got that, it's like four posts, and so there I would expect to find lines, but not in the canines. And so I don't think they're teeth for that reason. Also, some of them are very, very thick. There's another guy who's been suggesting that these are flower petals, the ancient flower petals that have petrified, and I reject that idea also because some of these are very, very thick, and if that was a flower petal, I don't know, maybe in some other antediluvian world there'd be flowers that look like that. So I don't think that it could be flower petals. Another guy said that, these are lumps of lava that got ejected into the air, cooled on their way down, landed, and then they just took on this shape. And I think that's also pretty silly personally. Here's another one, just like almost identical to this. So there's another really important distinction. There's your sulcus line again, and there's your blood vessel openings at the top. Couple of other ones. So some are black, which I think is fascinating. My friend Howard's collected a bunch of black ones, and you can see it's the same pattern over and over again. It's my handprint there. But like this is where you got to exercise discernment as well. Like this looks like a heart stone, right? It's got that harp shape, but I absolutely do not believe that this is one of them. And the reason is very simple. Those lines right there. I believe this is far more likely a chunk of one of the great trees, because this is exactly what all of these are doing, and I would refer to Hangman's research for that. But I'll show you what this looks like under water. So you can see the banding there. This is not what I would call a heartstone, even though it's shaped like a heartstone. So even a broken, fragmented piece of rock can still erode and take on this form. I'm not disputing that. But to say that these are that, if you dip these in water, none of them have this banding. When you see this sort of thing, I believe that is probably chunks of either tree or a larger tissue or something like that. But it's not. These are all encapsulated. They're like one piece. And as soon as they're broken, you can see a difference. Like here, for example. So that's not focusing. Hello. There we go. All right. So you can see the fleshiness there, and that piece broke off. If that piece was there, what would the rest of it have looked like? It would have looked just like all these other ones that I've been showing, right? Here's an example of what I'm talking about. As soon as there's a break, look at this, totally gray. You break it open, and look at how fleshy that looks. And if you look under the, with a 1000x microscope like I've done, you'll find that that it looks just like meat, especially something that's this red. You see the fascia, you see the meat. Here's one that's broken open, and you can see the blood and the remainders of the chamber. And then when I sliced them open, polished them, so you got the white outer portion, and look at that. See how meaty that is in there? Now people are thinking, well, you expect to see chambers like openings in here, but if you actually look at videos of them slicing hearts right down the middle, the chambers are far smaller than you would expect them to be. But this side I didn't polish because it's showing this either blood vessel or chamber remains right there, and everything else about it is that same pattern. And sometimes the blood vessels are white. Here you can really make it out. And yeah, so when I sent these stones off to the lab, I got no data back. I just got opinions, and all of those opinions towed the line on the mainstream narrative without addressing any of the research that I'd presented. So this one here is one of the ones I sent to the lab. The other half he kept, and he called these polycalcitic conglomerate cobbles, and the basic idea is that it's clay that has been compressed in a softer layer that then erodes away, and this pops out, and then the river action and the rain and that finishes smoothing it out, and that's how they take on this shape. And so I think he kept this one because this was probably one of the ones he could use to best make his case that this is just clay. But it would be really interesting to do like a blood test or DNA analysis. So if anyone has connections to laboratories or a bunch of money and they want a spring for that, fine, but I'm not going to do it. How can a heart petrify? There's so many different ideas that have been thrown my way. Some have thought that, oh, maybe it was some kind of a widespread ritual where they were moving the organs and somehow knew how to turn them to stone, which I thought was comical, but also ridiculous. And so why the organs outside the body? That's probably one of the most common questions I get asked, and I've made a bunch of videos. I call it boiled egg theory, and the idea is basically through some kind of a cataclysmic process involving great heat or electricity or plasma, that the outer portions of the body have been destroyed while the organs themselves have been protected in these fatty sacs, and then they're in a bigger fatty sac, which is the pleura, which is the chest and abdominal cavities, and that as the outer portions of the body are being destroyed, these are hardening like boiled eggs. They're wrapped in a very, very thick fatty layer called the pericardium, and that layer is the thickest on the heart of all of the different organs. There's a man who wrote me a comment in one of my videos that said that when his dog died, he put him on a pyre, and it was this very hardwood oak. It burned extremely hot for 36 hours, and in the end, all that was left was ash, and then a clump of what he thought was ash, and he poured some water on it to make sure that it had that it was out, the fire was out, and it revealed the heart, which was remaining there, and it was very, very tough. And I've heard similar stories from people who work in where they cremate bodies, crematoriums. So you can see here, this is a chunk that's broken away, and look at how fleshy that is. This is one of those ones, if you put it in water, it comes alive. See how red that is? So this is not oxidization because it's been exposed to the elements and that's why it's a different color than this. This is a different layer than that. And I've got other rocks where you can see the layer. It's not just changed color because of oxidization. So another stage of this whole journey was I got contacted by some guys that were in connection to a laboratory, and they were curious about these stones. The guy who owns and runs the laboratory is very reputable and he's prestigious acclaim or whatever you would say, and so he seemed like somebody who was really genuinely interested. So I sent off a dozen of these to their laboratory and made a whole video about that and their findings, or their claim of findings, I should say. So one of the things that reoccurs over and over again is this line. This is called the interventricular sulcus. And in the thumbnail to this video, in the lower left-hand corner, there's a little set of hands holding a heart. And those hands are the hands of Francisco Torrent Guasp. And he's showing that the heart is not what we were taught in school. It's actually what's known as the myocardioventricular band. You can literally unravel a heart into a flat, long band. And so when the electrical impulse that causes the muscle to contract it goes from one end to the other of the band. But because of the nature of how the band is rolled up, like in a knot, there's certain lines where the fibers are meeting, and those are called sulcus lines. And so this was another massive coincidence. You can see the remains here of this line, and on the back side as well. So on the back side, there's often two going down like this, and on the front side, there's one going in a curve like that. And that is, the helical heart. Somebody just mentioned it. I've made a video about that called helical, what is it? Helical hearts, petrified organs, and synchronicities, because it was an incredible synchronicity to discover this. So someone talked about the helical heart in the comment threads and said, "Oh, the heart is a rope." And I didn't know what they meant. And then later on, somebody repeated again and mentioned these two are twins. Look at how similar this stone is to this stone. This is what I'm saying: scalability, repeatability, all sorts of anatomical correlations that shouldn't be there if this is just a chunk of a rock. Now, the critics will say, you're cherry picking, you're going out and you're just picking rocks that meet your theory. Well, actually, it happened the other way around. I found a ton of these stones and they didn't make any sense. Initially, I thought they were mud fossils, but mud fossils work by being surrounded by mud, and then what's in the mud is leaching into the soft tissue and turning it to stone. That's mud fossil theory in a nutshell. It's called paramineralization. And that's recognized by mainstream geology as well. That's how petrified trees are said to form. The heart is a magnet. It's definitely vortexing, and the work of Francisco Torrent Guasp proved that not only is it a myocardioventricular band, this flattened thing with little twists that makes it function like a toroid, but it also the blood itself is not being pushed out but being suctioned in, and it's suctioned in like a vortexing spiral. So the heart is so incredibly far out compared to what we were taught in school. So the basics of what I've been showing people are you've got this harp shape, right, and often a flattened or curved underside. One side will be like a knife shape oftentimes, and the other side will be thicker, and it'll be a flattened top, and often there will be creases or indentations or actual openings where the big blood vessels, the biggest blood vessels of the body, the aorta and the vena cava, enter and exit the heart. So in addition to that, you get these sulcus lines that I've already been talking about. You get the fleshy look, you get the white outer shell, but they can take on many different forms. These are just the stones in this region that I live in, right? They're not. I haven't traveled outside of this region since pre-COVID. So I can't speak with any kind of authority about what's going on in other parts of the world. I can only speak about what I've seen here, both with the mountain and with the stones. Having said that, I have a Telegram chat that's set up where people who are interested in sharing their finds can go there. And I'm not in there very much because I'm drowning in social media already. But at least people can share and talk with each other there, and every once in a while I dip in. But those are that some of the examples that people have sent me are more beautiful than many of the ones I've presented. Cognitive dissonance, yeah. So I talk about paradigm blindness. You've got an expert in their field. They've studied this for years and years. They're the person that somebody goes to when they want to authenticate ancient artifacts and make sure that they're authentic. And so a person like that is, got a lot more of their ego wrapped up in the conclusions, right? Especially if their income depends on it. Yeah. So paradigm blindness. If I'm right about these things, if these are really petrified hearts, then clearly, many people around the world who are deep into geology have missed this. Do these heart rocks feel heavy or light? They feel heavy and they're hard. They're not hard like a sapphire or diorite or diamond or anything like that, but they're a couple steps down in hardness from those things. Some of them can be very porous, but that has to do with water erosion. Salt water starts to pockmark them, and I should have examples of that here, but I don't. So, something about the petrification process that negates rot. Yeah, I think it also probably happens very, very quickly, that it's maybe even instantaneous. And probably a lot larger in their fleshy form. Not necessarily. They're going to contract when we die. The heart goes into contraction. So the heart muscle needs oxygen in order to relax. So as we die, the fibers of the heart are actually going to go into contraction, and so you're going to get that twisting, and that's why so many of these exhibit this twist at the bottom. It's like a propeller, right? So that's because of the nature of the heart fibers that are contracting. I can give lots of examples of that. That one's not so obvious, but so those are incredibly specific finds. See that twist there? Yeah, so I don't believe they're teeth. I don't believe they're lava globules that were ejected into the air. I don't believe that they're just random stones that have broken off of larger pieces and rolled around and just magically eroded in this way. That makes no sense to me whatsoever based on the empirical findings. And yeah, so that is what I think of that. Repeatability, scalability, specificity, right? I've got this list of the Heartstone coincidence list, and there's like 25 different features on there. The top 7 are the harp shape, the curved line on the front, the 2 curves on the back, those are the sulcus lines, the top, the indentations for the blood vessels, the twist at the bottom, the faceted front, the curved backside. They can take many other shapes and forms, but those are the most distinct. Those are the easiest to spot. They're the most geometrically significant. And in fact, I'd like to at some point do a 3D rendering. I bought that platform over there with the intention of doing that. I've got green fabric, and I was going to mount these things and then record them in video as they're spinning, and get high definition, really nice coverage of all of these different stones in 3D. And then someone could take that and they could render it into CAD software, plotting key points, and actually use that as a way of seeing if there's some kind of a geometric significance in the way that these are manifesting, even if they've been altered by the petrification process. And that goes back to what I was talking about before with the DNA testing. My suspicion, even if I had a test to do, is that it's probably not going to come back positive for DNA unless it's a really wet specimen, because likely whatever caused it to turn to stone was so powerful that it's going to denature the molecules of DNA. So whether they would find something or not, I don't know. Yeah, so scalability, specificity, predictability. There's been several times where I've seen things that were partially buried and then uncovered the rest of it, and it was like just what I expected to find. That shouldn't happen if it was just random chance and these were just rolling around. Slicing them open, breaking them open, the lab work, endoscopic cameras, microscopy, CAT scan, people who say that I'm just, this is conjecture, this is all speculation, I don't have any scientific evidence. What's your definition of evidence? One man's evidence is another man's anecdote, right? So, yeah, and then I've categorized them by different types as well, and so I don't believe they're conglomerates. I don't believe they're globules from volcanoes. I don't believe they're shark teeth. That was another one. If you look at shark teeth, they do kind of have the same shape, but the upper portion where the tooth fastens into the jaw of the shark is a completely different kind of material than the main tooth itself. So you wouldn't expect these to be uniform with the same kind of material all around if they were shark teeth. So if you look at these and then you compare those to shark teeth pictures, I don't believe that. Yeah, so then, this gets back to Occam's razor. We're taught one set of beliefs about these things, but if we see them and we recognize, oh wow, these are exhibiting, these anatomical features, and we start to look at it and we find over and over again that it's repeating itself, then that is, then it's possible that it may actually be that, right? Occam's razor, the simplest explanation, being, all things considered, being most accurate in most cases. Paradigm blindness, the trees, things are proof of concept. I've just shown it to you. And logical consistency. So my scientific evidence is not based on an experiment, because there's nothing to experiment with. People could take these into a laboratory and do different kinds of tests. I'm not qualified to do that, but there's nothing to modify here. These are already as they are. So unless somebody can take a heart and petrify it and prove that it's possible, then this will stand still for a while as far as the research goes. What is the composition of the heart stones, like minerals like salt, calcium? That was what I originally wanted to know, and that's why I sent them to the lab in the first place in New Mexico, because I wanted to find out what is the breakdown of the different elements that are in these stones. Because if I can get a percentage breakdown of, oh, it's got this much calcite and this much iron, and these different constituent components, and get those by percentage, you could compare that to a fleshy heart and compare it to these stones. And if there is a similarity there, that would just be a huge, a huge proof in favor of the theory. What I would expect to find, though, is some kind of a transmutation occurring, because it's obviously gone from flesh to stone, so something has changed. And so as it goes through that process, there's likely to be an elemental shift in one way or another. So I would expect there to be a list of elements, and then this list might have similarities and other things that are maybe just off by one element, like, oh, this one has one more electron or one more, you know what I mean? That was what I thought was going to happen in New Mexico, and instead I got a survey of what 100 people thought the stone looked like. Literally, that's what I got. It was a joke, and they ought to be ashamed of themselves. So, and then they tried to make me look like I was in it for money, and I was all of these things that I had already addressed in all of my videos. They didn't bother to watch those, I guess. Yeah, so composition remains to be seen. Minion, what was that? Minion makes a portable USB DNA sequencing machine for €1,000. Sounds interesting. Happy to put it to use if someone wants to send it to me. Do you think that it's possible? Yeah, I mean, spectroscopy is an expensive thing, but this guy owned the lab, so they reached out to me. They were the ones offering analysis. They were the ones who offered to pay for samples, and I rejected that because I just wanted the data, and then I got no data. So I made a video about that with all of all of the correspondence and the phone calls, and it's a 3-hour video, and it's well worth watching if you're interested in the scientific method and how somebody with really alternative ideas that don't match with the mainstream beliefs can be handled when attempting to have some kind of a mainstream confirmation. Yeah, so it's been an interesting journey. I'm not sure exactly how much more I can do with this. It's going to take some other people stepping up to the plate that have access to laboratories, have moolah. If I get a good vibe from people, I'm happy to send some examples, and continue with it. But as far as scraping up the money to do DNA tests and do this, that, and the other thing, spectroscopy, which can run in the thousands of dollars, I don't have the means to do that. Yeah. Oh, I was talking about synchronicity earlier. The Francisco Torrent Guasp, the guy that discovered the myocardial-ventricular band. When I saw his videos and I realized that a lot of these stones that I had already been collecting and showing had these lines in them exactly where he was folding up the heart. And like I say, the thumbnail to this video shows the back side of the heart. When he folds it back up, there's two little curved lines going down. I've got a bunch of rocks that at the top, they've got two curves going down. How specific is that, right? And so I learned about that by watching these videos about the life of Torrent Guasp long before I realized that he lived and worked his whole life just on the other side of the mountain from where I am. He passed away about 15 years ago, but what a coincidence that this cardiologist that gave us so much knowledge about the human heart or about all hearts lived and worked his whole life just a stone's throw from here. That's just another crazy synchronicity. Along with the river name, where I found a number of these rocks, Gata de Gorgos, Gorgos being Gorgon, being the sister, the three sisters that were, one of which was Medusa. So it has to do with instant petrification. It's just like too much lining up. So sometimes things are what they appear to be, no matter what the rest of the world believes. And that's not to say that I'm 100% certain that I'm right about this stuff. Found this one just the other day. It's a beauty. And it's got those dents right there at the top. The dents won't be on the bottom. That's another specificity. They'll be at the top for the blood vessels, but if I pick up the vast majority of these, there's no dents on the bottom point. It's just at the top flat part. So just another coinkydink for you. So I showed, this is one of my favorites here. This is a beauty. Blood vessels at the top. And you can see the sulcus line there. And that sharp thing and the curved underside. This one here is remarkable. There's your interventricular sulcus line. And look at how meaty and fleshy that one is.
Did you know that almost everything you were taught about the heart is wrong? Most everyone today, even doctors, still believe the heart to be a 4-chamber pump that pushes blood through a mind-boggling 60,000 miles of narrowing blood vessels to fuel our 40 trillion cells, then filling again as if by magic on relaxation. Well, that theory was thoroughly debunked by the Spanish cardiologist Francisco Torrent Guasp back in 1972. After dissecting thousands of hearts, Guasp finally discovered the heart's true structure. The heart's far more amazing than we ever knew. It's like a rope, a long tube wrapped into a knot. Instead of being pushed, the blood is pulled through the heart in 2 spiraling vortexes. This has been proven with CAT scans, functional MRI, and positronic emission. Look at the spiraling contraction. It changes everything we know about the heart and circulation. If you'd like to know more, check out these videos.